Example 1. We are going to compare the square root of 3 plus 5. Is that greater than, is that less than, greater than, or equal to 3 plus the square root of 5? Okay, in order for us to solve this, we have to find perfect squares. Perfect. We also need to put them in order, right? We have the square root of 1, square root of 2, square root of 3, square root of 4, square root of 5, and it continues going on forever. Now, the square root of 3 is between the square root of 2 and the square root of 4. The square root of and the square root of 1. I'm going to use the square root of 1 because that is a perfect square, because we know that 1 squared equals to 1, and also the square root of 4 because that is equal to 2, because we know that 2 squared equals to 4. I am not going to use this 2 because that is not a perfect square, so it's not going to be helpful. So I'm going to say that the square root of 3 is in between the square root of 1 and the square root of 4 because those are our perfect squares. And based on that, I'm going to numbers that I tried out. 1.8 would be too large, so the closest estimate is 1.7. We're going to say that the square root of 3 is very close to 1.7. It's not equal to it, but it's a close approximation. Now we are going to do the same thing, but now we are going to do it for the root of 5. Okay, so square root of 5, our next perfect square is square root of 9 because 3 squared equals to 9. So you go, you notice 1, 2, 3, those numbers square, 1 squared, 2 squared, 3 squared. So the next perfect square would be 4 squared. But it is a lot closer to 4 than it is to 9 because it's right next to it. Versus 9, you have to do 6, 7, 8, 9. So it's too far. So I know that it's close to 4, so I'm going to use that to find my approximation. So I'm going to say, notice I started at 2.5 and that was way too big. So then I went down to 1.1 and that was way too small. Then I tried 2.3, that went over. So my closest estimate would be 2.2. That the square root of 5 is very close to 2.2. Okay, so now we plug them in into our original equation and see which one is greater. So we had the square root of 3 plus 5. How is that compared to 3 plus the square root of 5? So we know that the square root of 3, we know that that is very close to 1.7, and then we do plus 5. And we know that the square root of 5 is very close to 2.2. Okay, so from there we just add them. So 5 plus 1.7 becomes 6.7, and 3 plus 2.2 becomes 5.2. So 6.7 is greater than, and we can say that the square root of 3 plus 5 is greater than 3 plus the square root of 5. And that would be our answer. Now we did it together. You have that answer. You should already have that answer. So now do 3 and 4. On the previous example, we were comparing irrational numbers. Now we are going to order real numbers to make a list from least to greatest. Okay, so we have these numbers right here. It says order the square root of 22, pi, 1, and 4 and a half. So for us to be able to order these numbers, first we have to make sense of the square root of 22 because that is not a perfect square. We are going to get a very random number. So um, squares. And 4 square is 16. I mean the square root of 16 is 5. So the square root of 25, and 22 is in between the square root of 6, the square root of 25. So it's closer to the square root of 25. So let's try to guess. Numbers, we can see that this is the closest without going over. Now 4.7 was very close, but it did go over. So we are going to stay with 4.6 because that is the closest without going over. An approximation to this pi, we know that is really close to 3.14. Number 1, then we have 4 and a half. So step 1, identify. Step 1, make sense of the numbers. Step 2, I'm going to create a number line. I don't have any negative numbers, so I'm going to put 0 here. In that other direction. So now let's plug in our numbers. Okay, we have 1 here, here. Another number that we have is 4 and a half. So that one goes over here. Another number we have is pi, which is 3 and 14. So 3 and 14. So here, right? But it's more than 3, so somewhere around there. And our last one is 0.6. 4.6 is greater than 4.5, so somewhere around here. Okay, so we have our numbers in the order. Now that we use the number line, and then we just follow the order. So we would have 1, comma, the next number is pi, 3, and ordering your numbers from least to order numbers from least to greatest again, and then graph them on the number line. They did a number line for you, so all you have to do is do step 1 and then plug them in. So do number 5 and number 6. The next part is ordering real numbers in a real world context. Okay, so calculations and estimations in the real world may differ. It can be important to know not only which one are the most accurate, but which given the greatest or least values depending upon the context. So basically what we did before, but now we are going to put it into context. Example 3. 4 people have found the distance in kilometers across a canyon using different methods. The results are given in the table. Order the distances from greatest to least. Now we are going to put them in the other order. So we're going to start with the greatest and end with the least. So we have 4 people: Juana, Leon, Rainy, and Jackson. And these are the results. So the first thing that we want to do is we want to make sense of the numbers that are irrational. For example, the square root of 28. That is not a perfect square. So let's look at our perfect squares. We know the square root of 25 is equal to 5. So the next one would be 6. 6 times 6 is 36. So we know that the square root of 28 is between 25 and the square root of 36, but it's closer to the square root of 25, so we are going to keep it closer to 5. So then we just plug in numbers to see which one makes sense. So we are going to keep 5.4. It is somewhere close to some numbers kind of make sense, but we want to change them all into decimal format so that we can plug them in on a number line. So now we have 23. We have to change that to a decimal so that it's easier to compare. So 23 divided by 4. So this is 5.75, and the next one is already in form, so repeating decimal, so we're good there. And we just have to find the next and change it to a decimal form. So remember, we are going to do 5, and well, I know half is 50, so we're just gonna leave it like that. Alright, so remember, to make things even, we are going to put a 0 here, and this one is repeating, therefore there's another 5 right here. So that now I can go ahead and make my number line so that I can order them from greatest to least. And it looks like all of them are between 5 and 6. So I'm going to start with, now let's start with 5.40 is right here. And then we have 5.75 just down here, 5.75. Then 5.50 right here, 5.50, and 5.55, repeating 5.55. Okay, so now we can see that the greatest is 5, then it's 5.55, and it's 5.50, then it's 5.40, or if you wanted to keep them in the original numbers, you can do that. You can say 23/4 is greater than 5.5, repeating which is greater than 5.5, which is greater than the square root of 28. Go ahead and do number 7, and then on the guided practice, do 1, 4, 5, 8, and 11. Okay, and then I'll see you again.